So it says my name's Craig Sheridan. I'm currently the managing director of a company called flexiOPS based just outside Edinburgh. We were a spin-off of a cloud company called Flexiant, who you may have heard of. So I'll try to explain a little bit about that history in a moment and where I'm coming from and try and contextualise that with where we're trying to go now. So cloud computing, there's a lot of talk recently about whether it's a utility or not. Yeah, in my opinion, yeah, absolutely it is. In fact, it's something we have been saying for around 2 years, in actual fact, you know, before it was common and popular to say things like that. We're seeing now, we're getting over the peak, you know, of the expectations and the hype of expectation that you see in the Gartner hype cycle. It was something we experienced actually in a very negative way. When you create very good software and you're ahead of your peers and you create things and bring them to the market quickly, it certainly doesn't mean that people are going to buy it and they're ready to actually use it and take that dive and migrate their legacy applications. And indeed, we were a bit of a victim of that. But we're seeing now people actually willing to migrate their legacy applications over to cloud environments more and more, certainly. And when you see this increased adoption, you then have a sort of large customer base of various types using the cloud, and of course demands then start to increase about what it is they're using and how it's used, certainly. So providers of cloud environments then have to ensure that those environments are highly resilient, you know, in supporting solutions like the HA and the disaster recovery that Florian presented yesterday in OpenStack. And to test behaviour of services under certain conditions, I think, is very important to people rather than just throwing their application into the cloud and crossing their fingers. So the ability to then create then a series of anomalies on demand is clearly a useful thing that's been identified. So I'm going to discuss the motivation, innovation, design, a running example, not live, and the future development of a fault injection tool. So I'm going to cover, firstly, to contextualise things, something about cloud evolution. I'm going to contextualise this around a Horizon 2020 project that we're involved in called DICE. I'll give a technical overview of that, although it's not the main part of the presentation. I'll talk about the problems, objectives and positioning of that project, the demonstrators that are being used, and then I'll have a deep dive in particular into the fault injection tool that we are creating. So the tool itself, it enables controlled causing of cloud platform issues in service and virtual machine level stress outages, that kind of thing. The purpose being to observe the subsequent effect and deployed applications. It's designed for use in a DevOps workflow, the idea being to have tighter correlation between application design and cloud operation. So it helps improve resiliency levels for data-intensive applications. It does that by bringing together fault tolerance, stress testing, and later benchmarking, anomaly detection as well. We're not doing that yet, but this is the plan sort of going forward in the future, and really gives application owners a better understanding of target environments and how they should be used. I'll also mention something at the end on Horizon 2020 and absolutely why you should invite us to next April's cloud projects and things like that as a wonderful partner, and we'll host you in beautiful Edinburgh. So the evolution of the cloud, and I'll try and explain at the same time, contextualise a bit how flexiOPS sort of came about. Because flexiOPS actually really evolved through this cloud evolution channel. We started life as a company called Excalibur, actually, and I'll explain something about that in a minute. So the cloud evolution, we had desktop machines. It would give you a bad back, you know, as you see in the I don't know why they're called desktops, actually, when they were underneath the desk, right? And you were always under there fiddling about with cables and things like that. pre-cloud hosting. So it involved the best thing you could really do with these desktop machines. You know, it's just a local operating system and a local machine. You could partition the hard drives, you know, create a local division. Great, fantastic. Then things moved on to sort of data center centralized hosting. And this is what we did as a company called Excalibur Communications in Scotland. We were a hosting company with very large amount of space in various data centres in the UK. So we would do all of those nice things like host people's websites. We would host POP email servers. We would host DNS servers. We were a domain registrar, we would host load balancers and all of these nice type of things. We had a very large customer base, and what differentiated us really as a company then was that we used to really properly listen to our customers and what they wanted, and we tried to go that extra mile. So technology moved on. Virtualization became a thing. Virtualization has been a thing for decades, but I mean virtualization in the sense of hypervisors became a thing. We were very quick to realize the power of hypervisors as a company. And while we were a hosting company, we developed a cloud platform. So this was before anybody was talking about the cloud or there was such a thing as a cloud. We were developing a cloud platform before any other platform existed in the marketplace. When we released that public cloud platform, it was the first ever public cloud in Europe. Amazon released the very first public cloud 3 months before we released ours. So we're hoping to have a world's first to release the first ever public cloud. We didn't know Amazon were developing one. We could have actually released it just before then if we had known. But the first in Europe, you know, it's not a bad achievement for a small Scottish SME. So we were pretty pleased with ourselves there. So that really is where we sort of got a lot of fame, being a sort of early adopter of these technologies, recognising quickly what could be done and developing a customer-facing platform and building this layer of all of the functionalities we considered that users needed. So from there, things developed further. Clouds, it starts to become a sort of commodity hidden in the back end. And we arrive at a kind of place where people are now sort of talking about how the cloud will be consumed in the future. I would contextualize that as, if you can imagine perhaps a sort of series of horizontal layers on top of each other, and some of the other presentations might have touched on this actually. But I might do it in a slightly different way. If you imagine a front end that's supporting things like SLA, billing, and a service repository or an application repository, very user-focused, very user-facing, I think that this is how people will want to actually deploy their applications. Underneath that, maybe a networking layer supporting NFVs, the type of things that Dimitri from Brocade took a deep dive into, SDNs. But then an infrastructure abstraction layer where all things cloud-related live and hide behind. Things such as the VMs, containers now, physical storage and compute nodes. So consumption will then consist of provisioning a slice through those layers. And this is something that isn't quite happening yet, but that end-to-end service is going to involve quite a few different actors to provide that end-to-end service. So it's going to be a vertical slice through those horizontal layers is how provisioning is going to, and cloud consumption is going to happen in the future. And that will include especially, I should mention, although I'm not going to dive into that, the ultra-efficient application containers. The best example of which I think undoubtedly is Kubernetes. Those lovely people at Google have open sourced Kubernetes, which is a fantastic opportunity, I think, for lots of SMEs to sort of take that and work out how better to use that functionality. I mean, it has lots of, and it does a lot of things that other people have been working on for a little while and seems to do it quite well. I mean, it supports, you know, very easy input of sort of native language and things to sort of dictate how your deployment should be and how it looks. It has excellent built-in resiliency. It has self-healing properties. It works over multiple clouds. And really, these sort of technologies together and working together, you know, in top of the cloud space is really now the cloud becomes the perfect home for microservices, and really it's where IoT then starts to meet that cloud. So that's how now we can start looking at end-to-end, especially with the networking NFVs involved, end-to-end solutions for the first time. And I think telcos will probably be the people that are mainly going to provide those services, but there's certainly opportunities for service providers and third parties to be involved in that model. The more observant amongst you will notice that the slides are branded as DICE. So this is a Horizon 2020 project we're involved with. The work of the fault injection tool that we're developing is being done in this context. It's a research and innovation action started in 2015. It's being run by Imperial College in London. It's the only project actually we've ever been involved with. At its first review, it received an excellent from the European Commission. Now, you would think this was a good thing. The coordinator, no. To him, it was the biggest disaster that had ever happened. He had his head in his hands because he thought everyone's going to stop working after year one. Now we've got the excellent review, everybody will rest. So he was in a crazy panic about this. But there's a lot of good partners in that project for sure that looks as if it's going to be very, very successful. Everybody's trying to really go above and beyond what's expected. So I've told you a little bit about, you know, where flexiOPS came from, the evolution of cloud computing becoming a utility part of a service chain, and the need for sort of highly resilient solutions for demanding service providers who'll use it as that end-to-end service I mentioned, and telcos probably being the ones to do it. So there's the partners involved there in this project. And although I'll give an overview of this project, I'll try to focus on the fault injection side, but it's actually only a small part of it. But I'll try to discuss the motivation, the innovation, the design of all of that area. So the DICE framework, to put things into a bit of perspective, it's an IDE-centric solution, so UML profiling, and tools for software designers to reason about reliability, safety and efficiency of their data-intensive applications. So that happens via an Eclipse-based IDE and a DevOps methodology powered by a set of requirements for data, which I'll come back to in a moment, things like volume and velocity. Modeling of data technologies around the areas of quality analysis and verification. A semi-automated feedback analysis using monitoring to test data to improve design. And this idea of a continuous delivery and testing area for agile delivery, and that's really where our part sits as well. So this follows sort of principles of the, you know, we'll call it the emerging DevOps paradigm, although very clearly people like Google have used this for a long, long time, as we realised yesterday, and which came as no surprise, I think. So it will support things like monitoring, anomaly detection, trace checking in order for behaviours of services under certain conditions, using the ability to create a series of faults on demand. And the reason for doing this is that, you know, there's been this idea of a rapid growth in big data. So this is what's driving the increased adoption, really, around adoption and reliance on cloud platforms is a part of this service chain that I mentioned, and how big data can be used. All of these IoT devices capturing this data. The cloud was always a natural home, but it wasn't quite ready to do it properly. I mean, as according to I think it's undeniable that the shift has happened. The markets are shifting towards it. Everything's in the up. And basically the service providers, the cloud providers, the telcos as well, all have to react quickly to sort of prepare themselves and get ready for this and how it's going to be delivered. However, there's a massive business issue there. It's according to Capgemini, 65% of big data projects still fail. Okay, that's not contextualized very well. There's lots of different ways that these failures can happen, but if 2/3 of these projects are failing, then something's very, very wrong indeed, and mitigation must happen. So, as I say, we've always been customer-facing. Projects tend to sort of look at use cases as well to try and do things, and I'll come to that in a little moment. So it's all good and well, but quality-driven development, it has a skills shortage, which is one of the main causes of these big data project failures, and this is something that Gartner have identified as well. Software is written by inexperienced developers, which unsurprisingly makes it unreliable. Efficiency requirements are often secondary in the development cycle. So integrating quality assurance practices in application development can clearly reduce these type of failures and the mistakes that are being made at the moment, and the fact that 2/3 of these projects are failing. So very important for SMEs who often have no dedicated quality teams. They really can't afford to do it. They tend to just develop and throw things out to the marketplace and allow the users to be their guinea pigs, which is great in the sense that it saves money, but it's not great for your reputation as a small company if you're putting faulty software out into the marketplace deliberately. And outsourcing that work as well can be very expensive. Also, it can have mixed results as well. So there's no easy solution there, which is why the drive towards kind of automated and cheap solutions makes a lot of sense. And when testing, it's difficult to reproduce faults that are actually happening in production environments. So developing these specialist tools should be very useful. So the DICE approach to supporting data-intense applications is threefold. Firstly, the breaking down of data to a common set of characteristics to identify things like volume, velocity, privacy, location constraints, with an N missing from location there. Secondly, for data management and storage, big data technologies like NoSQL, Hadoop, Spark, CloudStorm, all very large updates. And then methods and tools to deliver that solution through UML, as DICE is doing from its model sort of based environment, and using the sort of DevOps paradigm, about how to actually deliver these services. So what do we mean by quality? So in order for any new solution to be successful, it should be able to prove its worth. So we plan to try and quantify and qualify our solution using a set of metrics attributed to these areas so that we have measurable and accountable use cases, and we have very good use cases in the projects, and we want to try and make sure we understand their problems, apply this solution, and we can actually show measurable differences that can make a difference in the marketplace in several ways. So the areas we've identified to sort of contextualise quality, reliability, efficiency and correctness, which breaks down to things like availability, fault tolerance, performance and costs, and privacy issues. So the objectives and positioning of the project itself, just to contextualise, several EU projects have explored model-driven and quality-driven development, covering enterprise applications like QMpress, service-oriented systems like Sensoria, and multi-cloud applications like projects like Moda Clouds that I was involved in as well. But DICE is unique in that it centres the focus on the data-intensive application, which makes it a very customer-facing solution. So it centres on the application itself rather than just the idea of that kind of parallel approach towards just processing sort of terabytes and petabytes of data. The use cases we have to try and prove this, Athens Technical Centre, they have something called a news asset platform which hosts services and applications for the news and media industry. It's a central point of the platform is a distributed multi-tier architecture engine for managing data storage, and it's composed as media items such as text, images, reports, articles, videos. So they're a developer of the type of big data applications that users need. So it should be very useful to help prove things in this project. And NetFective, they use market domain data to develop software for the French government, so a public sector use case, and it can link to the capabilities and needs of big data and e-government applications, which is a massive possible target market in actual fact. And ProDevelop in Valencia, they use maritime data like information from vessels and movements of continuously transmitted that are continuously transmitted by automatic identification systems such as radar and other sort of real-time navigation systems. And really that's all about safety critical situations, when it's being used as sort of for guidance techniques of ships. So reliability in instances like that are absolutely crucial. So we have an excellent set of use cases to try and prove what we're doing. So there's no use having a project if there's not some sort of clear advantages. So in order to support the development of high quality data-intensive applications, we aim at doing all of these things, tackling the skill shortages, steep learning curves, shortening the time that it takes to market. That's something we're making great strides on already, and the time that it takes data-intensive apps to actually go through a QA process and be released, and of course reducing the number of faults experienced when software is actually released as its first version to market. So now we'll take a bit of a dive specifically into the fault injection tool. Everyone loves a monkey, right? It's better than the usual cat, for goodness sake, too many cats. There was a reason for using the monkey, actually. We'll come to that. So the fault injection tool, what is it? It enables controlled causing of environmental cloud issues, such as being able to stress the resources and services, to mimic VM outages and the levels of seriousness that can happen. The purpose of that being to observe the subsequent effect in the deployed applications. It's being designed for use in the DevOps workflow, I mentioned before, for tighter correlation between that application design. So it's about design time as well as runtime. And its relationship to the target environments. So this helps improve resiliency for these DI applications, and we hope to cover sort of, now we'll speak about the sort of motivation of that, the innovation, and sort of tell you just where it fits. This is the sort of the same as the slide earlier on I showed, except it's sort of blown up a little bit more to show some detail in these different areas. So the fault injection tool, it's part of the continuous delivery part of the solution over here. That's the part that supports deployment automation and mapping of modelling to the real environments and handles all of the deployment issues and also runtime monitoring and sort of change adaptation. So the motivation for that part in particular, so robust testing, showing where to harden the application before it actually reaches a commercial environment. Application quality of service, resiliency is dependent on the underlying infrastructure, and that's very, very clear. If applications are developed in isolation, then you're going to have a problem, and this is really what this is all about. You know, trying to encourage people to develop applications with the target environments in mind and understanding where it should actually be hardened and changed. So this then allows the tool user to generate faults either at VM or cloud level, lets cloud platform owners test resiliency of a cloud installation and application target. So the actors within the fault injection tool area, data center owners, they can gauge the stress levels on infrastructure and thus offer advice to customers. They can identify and address bottlenecks. It helps give them opportunities to adapt pricing at various levels of quality assurances. And from a developer perspective, they can evaluate their application resilience and dependability, not only at runtime but design time, through forcing parts of the application to fail and testing it in different types of environments at different stress levels. So where's the innovation? I mean, you're really in these Horizon 2020 projects, you always have to be trying to go beyond the sort of state of the art and what anything else is doing. If we look at the fault injection part itself, I mean, there's lots of innovative aspects of the project itself, with a focus on the fault injection part only. Other tools exist, but they tend to be platform specific or have limited functionalities. Chaos Monkey only accesses AWS and has the ability to terminate VMs. That's where the monkey part comes from. So we decided to call our tool flexiMonkey as a sort of marketing idea based in Chaos Monkey, but expanding what they were doing. So also Kokoma, it's been developed, but it's not actively supported. When we looked at that, it suffers from high resource usage. It's very complex to configure and also has limited extensibility. So our tool, on the other hand, the plan is for it to support a whole range of functions, have greater flexibility, VM level faults that are cloud agnostic, which is a key thing. Cloud level faults, it's been deliberately developed to be very lightweight in operation, and only installs required tools and components that it needs in target VMs, and the fact that it can install it is quite an important feature as well. So it adds value then to the quality enhancement workflow. And from a design point of view, the fault injection part itself looks like this. A user sends commands. This architecture can run independently, importantly, and externally as well to any target environment. So really it runs as a third-party tool, not within the environment itself, which is a key feature. So it uses JSCH to SSH to virtual machines and issue commands as a predefined user, because of course as soon as you go to use APIs and things. You have to be authenticated on those platforms. It's been released under the permissive Apache 2 license, early versions at the moment. And the developers tell me it's been tested at the moment with Ubuntu versions 14, 15.1 and CentOS v7. So to give a bit of further context, so I mean, there's a list of the supported faults at the moment. I mean, it's not an exhaustive list. There's other things being worked on at the moment. So cloud level and VM level, that's split into. So you can see a cloud administrator can use a system API to shut down nodes. Inject high CPU onto the compute nodes, the same with memory, and deliberately control the amount of bandwidth in different parts of their environment. And there's a whole set of sort of VM functionalities there. So a user selects the fault from the command line. It's a command line tool. The fault is then invoked on the cloud platform or virtual machine. Required tools and dependencies are then installed and configured automatically, as well as any required APIs being invoked. The fault then is injected and is logged, and the fault completes, and the status of the whole run is then recorded into a log. That's probably the simplest possible example that we could have. I mean, there's a whole wealth of command line switches that we've built into this already, but I won't go through those. But and all of those have their own parameters. But it allows users to select a specific fault to be injected, and control when it's going to happen, and the parameters around that, such as the amount of RAM, which services to stop and things like that. So here's an example of a command line call to connect to a node using SSH credentials and stress the memory with 2 gigabytes. So that was the result of running a call in a real system. The tool connected via SSH to the VM determined the OS version by checking etc release for the version of the OS, Ubuntu in this case. Looked for the memory stress tool that's suitable for Ubuntu, in this case, which would be memtester. And if that tool isn't found, then the fault injection tool then installs that automatically along with any dependencies. And finally, the fault injection tool calls memtester to then saturate the memory in the target node or VM. So the figure shows the result of this is detected by a monitoring tool showing nearly all of the 2 gig of RAM available to the VM being saturated. So just the simplest possible case. So the conclusions in future work. So the fault injection tool, it's easy to use, easy to integrate. It's a command line tool. Reduces uncertainty about reliability of applications. It's being designed for use in a DevOps workflow, as I mentioned before, for tighter correlation between application and design and cloud operation, helps improve resiliency for data-intensive applications and brings together fault tolerance, stress testing and benchmarking. Anomaly detection is the sort of next step towards what we're going to bring into this environment as well through some collaboration in the DICE project, hopefully. Future work will also cover some of these things listed in the slide here. Consider different topologies, operating systems, different types of infrastructure, and especially containerized environments because of the importance of those, for a future choice of people running their microservices. And with that, I'll just remind people that we have a long success. The people that work for flexiOPS under different guise out of FlexAint, but in many projects we've managed to bring many tools to the marketplace and many features. The FlexAint Cloud Orchestrator software that is running out there. The easiest way to see that, there's a public platform called FlexiScale. That contains many of the features that have developed within these projects, and it's one of the most advanced cloud platforms on the planet. So we plan to attack next April's cloud computing call, so please contact me if you have any ideas there for taking anything forward, anything cloud related and now quality assurance related, because that's going to be part of our future focus. Also, so I'd be happy to take any questions. Thank you very much for listening, by the way, much appreciated, and thanks to George for the invitation as well. And I've enjoyed all the other presentations as well, very interesting. I've took lots and lots of notes, and I'll probably be giving you guys a shout, and I'll start harassing you about things in the future. Thank you.
Any question?
So this tool for fall injection, is any plans for open source this thing? Or?
Yes, actually, that's the direction we want to take it, very much so. So I think I mentioned in the presentation that we've released an early version of it under the Apache 2 license, and we plan to continue to do that. So we plan it to be an open source tool, and we plan to encourage data center owners to use that, because one of the problems actually with data centers, I mean, we run a test bed using flexiOPS Cloud Orchestrator software, and we have full access to all levels of that. So we are able to sort of utilize that particular platform to inject the cloud level faults in there and control that. But I mean, of course, if you go to use Amazon's platform, you don't have the same opportunity to actually do that, or you go to use any of the public platforms, you don't tend to have that opportunity. So we want to release it as an open source tool, and also say to these public platform providers, you know, that we can make sure this tool is suitable for your environment, explain to them how to use it, allow them to use it for free and power their environments. And then the VM level one is something that should be able to run agnostically as a third-party tool very easily for anyone to use. And we see the commercial opportunity there just to sort of utilize that, you know, around support, you know, area as a service provider, you know, to take all the complexity and the hard work out of that on behalf of people who want to migrate legacy applications to the cloud. So yeah, open source is the direction we want to go with it.
So, yeah, like, so just to clarify, right now we can access these early versions you mentioned, right?
Yes, I don't think I have. It's on. Yes, it is on GitHub.
Okay.
If you visit the I think it's the dice-h2020.eu project, such a very non-commercial type, you know, website name there. But all of the links are up there to the various tools that are being developed, and the whole project actually is being designed to be open source. All of the tools that are developed should all be released publicly. Yeah.
All right. Awesome. Thanks.
Is it based on OpenStack or?
No, the idea is actually for it to be cloud agnostic. I mean, we've been doing the work and the testing based on FCO software, flexiOPS Cloud Orchestrator software. We have done some testing, though, in an OpenStack environment as well. And some of our future work will involve just making sure that especially the virtual machine level faults can be injected to any chosen target platform, you know, just using a sort of intelligent virtual middleware integrator and building sort of custom drivers towards each API of the different environments. I mean, that work actually is something we done when we developed a tool called Concerto as flexiOPS, actually, because we had a deployment tool there that worked across all of the known public environments. So it's something we have a history of already, and how to actually, you know, be cloud agnostic while developing tools. So that's the plan there. Yeah.
Right. Thank you.
Thank you.